Okay, here is warm-up number 38. So this has a function here, and I'm going to find the inverse of this function. It's a little hard to read, but that says f to the negative first. Well, not to the negative first, really, but that is supposed to be a little negative symbol in there, which means I'm finding the inverse of f of x. Okay. All right, so what I'm going to do, I'm just going to pretend this is a y, and I'm going to switch the x and the y to begin with. I'm going to do this up here because I think I might be a little low on space on this problem if I don't use this room up here. So I'm going to write this as x equals 3y squared minus 5. Okay? And then my goal is going to be to isolate y. So I'll start by adding 5 to both sides. So then x plus 5 equals 3y squared. Okay? And next I'll divide the whole equation by 3. So x plus 5 all over 3 equals y squared, or you could split that into x over 3 plus 5 over 3. It doesn't really matter. Okay, and then I want to isolate y still, so I'm going to take the square root of both sides. And when I do that, on the left side, I got to remember there's a positive and a negative square root. Okay, so then y is going to equal positive or negative square root of x plus 5 over 3. Okay. And then the last thing is to just put that in back in function notation. So the inverse of function f is going to be this. Okay. All right. Now, next up, let's graph on number 2. Let's graph this function, function f, and its inverse on the same axis. Okay, so looking at the original function f, it's a parabola. So for function f, my vertex, I'm going to take this, set it equal to 0. So x would equal negative 1. And then the y value is right there. So the vertex is negative 1, 2. Okay, it's going to open upwards from there. And I'm just going to follow the parent graph because there's no stretch or compression. So it's going to look like that. So this is going to be function f. So I'll just label that f of x so I know which one's which. Okay. Now there's a couple of ways to graph the inverse. One thing I could do is find the inverse like I did on number 1 and then work on graphing it from there. But you can also just take this and do a reflection from this, because a function, if you graph its inverse, it's just going to be the reflection of whatever the graph is over the line y equals x. So you got to know what the line y equals x looks like. It is a diagonal line that goes through the origin like this at a 45-degree angle. Okay? So I'm going to reflect this, so you can think about folding the paper in half, and you'd have a parabola that's going to open to the right somewhere down here. Okay? Now to get a little more accurate, you can just take the points one by one. So this is the point negative 1, 2, where my vertex is. So if you just switch that xy pair, it's going to reflect that over the line y equals x. So instead of negative 1, 2, I'm going to graph 2, negative 1. That's right there. Okay? And then I can do that with the other 2 points. This is negative 2, 3. So if I swap that xy pair, it'd be 3, negative 2. And then this is 0, 3. So swap that, and it's going to be 3, 0. And then you can see where the parabola is going to end up, right? It's going to be opening to the right, like so. And so this is the inverse. Okay? All right. Next up is f of x a function. That's what I have graphed here. So I'm just going to do the vertical line test. Okay? So this is the vertical line test I'm doing just for reference. So this is going to pass the vertical line test, right? Anywhere you put a vertical line in, it's never going to pass through more than once. So it passes through once over there. So this passes the vertical line test. That means this is a function. If I want to know if its inverse is a function, I'm going to do the horizontal line test and see if it passes or fails the horizontal line test. And this is going to fail the horizontal line. If I put a horizontal line in, say, like this, well, that wasn't a very flat one, but you get the idea there. That's going to pass through 3 times. It's going to fail the horizontal line test. That means that the inverse is not going to be a function. You could, try to graph the inverse by reflecting this all over y equals x, but it's much easier to just do the horizontal line test to test its inverse. Okay. Next up, got some function notation. This is not just multiplying these two functions together. This is going to be a composition of functions. So this is going to be equivalent to f of g of x. Okay. And then I start on the inside with the innermost function. I'm going to substitute in this for g of x. So this is going to be f of 3x squared. Now, in function f, this is going to be my input. So going to function f, here's where the input goes. So I'm going to replace the x with 3x squared. Okay? So it was something minus 2, right? Something minus 2. That something is 3x squared. And then I simplify that as much as I can, and there's really not anything I can do with it at all other than write it without parentheses. And there we go. Okay? All right. Now let's determine by composition if these two functions are inverses of each other. So, you know, again, you could just find the inverse of this one and see if it's that, but that wouldn't be by composition. By composition, I want to see when I find f of g of x, does it equal x? And then, if it does, I check g of f of x and see if that equals x. So let's see. So I'm going to replace g of x with that fraction. Okay, and then I'm going to input the fraction into function f, so I'm going to replace the x with the fraction. So it's 3 times something minus 7. 3 times something minus 7, that something is the fraction. Okay, and now we'll start simplifying. So hey, the 3's cancel, and then I've got x plus 7 minus 7, and the 7's also cancel. So hey, that did come out to just x, so I passed that part of the test, but I still want to check g of f of x. And if this also equals x, then those are indeed going to be inverses of each other. Okay? So I'll replace f of x with 3x minus 7. So this is g of 3x minus 7. Okay? Now this is going to be my input in function g. So in function g, here's the input. So I'm going to write that fraction. It's going to be something plus 7 all over 3. Something plus 7 all over 3. That something is 3x minus 7. And I'll start simplifying. So on top, I've got negative 7 plus 7, so that leaves me with 3x over 3. Now the 3's cancel, and hey, got x again, so my answer is yes. So if you get anything else besides x out for f of g of x or g of f of x, then they're not inverses of each other. Okay? That's it for this warm-up, and I'll see you next time.